Hello friends, welcome to this video where we are going to learn basic proportionality theorem. This theorem was introduced by a Greek mathematician, Thales. Hence, it is also referred to as Thales theorem. He gave this topic based on his studies on similarities of triangles, which says that in equiangular triangles, the ratio of corresponding sides is always same. Basic proportionality theorem states that if a line is drawn parallel to one side of a triangle intersecting the other two sides in distinct points, then the other two sides are divided in the same ratio, or we can say that the other two sides are divided in equal proportions. So, we are given with a triangle ABC and a line DE is parallel to the side BC. According to the statement of the theorem, we need to prove AD upon DB is equals to AE upon EC, or AD upon AB is equals to AE upon EC. Now, in triangle ADE and triangle ABC, angle 1 and angle 2 are equal, and angle 3 and angle 4 are also equal. As you can see in the diagram, they are pairs of corresponding angles. Therefore, triangle ADE is similar to triangle ABC by AA similarity rule. So, we can say that the corresponding sides of these triangles are in proportion, that is AD upon AB is equals to AE upon EC. By taking reciprocals of these ratios, we get AB upon AD equals to AE upon AC upon AE. Now, applying dividendo, which means subtracting 1 from both the sides of this equation and then taking LCM, we get AB minus AD upon AD equals to AC minus AE upon AE. From the diagram, it is clear that AB minus AD is BD and AC minus AE is EC. So, we get BD upon AD equals to EC upon AE. Again, taking reciprocals of these ratios, we get our required result. AD upon DB equals to AE upon EC. Thus, if we have a line drawn parallel to any one side of a triangle intersecting other two sides at two distinct points, then those two sides are divided in the same ratio. Hence, basic proportionality theorem is proved. Now, let us see a few questions based on basic proportionality theorem. The first question says that in the given figure, AD is 1.5 centimeter, DB is 3 centimeter, AE is 1 centimeter, and DE is parallel to BC. And we need to find the length of EC. So, the solution is, since we have DE parallel to BC, we can use basic proportionality theorem, which says that AD upon DB is equal to AE upon EC. Now, substituting the given values, we have 1.5 upon 3 equals to 1 upon EC, and by cross multiplication we get EC equals to 1 into 3 upon 1.5, which is equal to 2 centimeter. Hence, this is the required answer. One more question on basic proportionality theorem. The question says, in the given figure, DE is parallel to AC and DF is parallel to AE. Prove that BF upon FE equals to BE upon EC. So the solution says, in triangle ABE, it is given that DF is parallel to AE. So using basic proportionality theorem, we can write BF upon FE equals to BD upon DA. Say this is as result 1. Now in triangle ABC, again it is given that DE is parallel to AC. So again using basic proportionality theorem, in this triangle we can write BE upon EC equals to BD upon DA and say this as equation number 2. Now if we observe equation 1 and equation 2, the right hand side is the same ratio. So from 1 and 2 we can say that BF upon FE equals to BE upon EC. Hence our required result is proved. Okay, one more question. It says, in triangle ABC, DE is parallel to BC, and then find the value of x from the diagram. So we now know that if a line segment is parallel to one of the side of the triangle, here we have DE parallel to BC, then we can use basic proportionality theorem and we can say the other two sides are divided in proportion. So we can write x upon x plus 1 is equal to x plus 3 upon x plus 5. On cross multiplication we get x squared plus 5x on left hand side, which is equal to x squared plus 4x plus 3 on right hand side by multiplying using distributive property. We can see x squared terms on left hand side and right hand side, so we can cancel them, and transposing 4x on left hand side we have x is equals to 3, which is the required answer. Okay, after solving few sums on basic proportionality theorem, it is time to check the next theorem. In basic proportionality theorem, we saw that if a line is drawn parallel to one side of a triangle, then the other two sides, remaining two sides, are divided in the same ratio. Our next theorem is converse of basic proportionality theorem, which says that if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side. That means the given details and what we need to prove in basic proportionality theorem are interchanged in this theorem. We are given with the ratio of two sides in triangle ABC, AD upon DB is equal to AE upon EC, and we need to prove that the line DE or the line segment DE is parallel to the third side of the triangle BC. Now let us assume another line and construct it. That is construction DF parallel to the third side BC of the triangle. Now since DF is parallel to BC, we can use basic proportionality theorem, and we can say that AD upon DB is equal to AF upon FC. But in this theorem, it is given that AD upon DB is equal to AE upon EC. So with these two equations, we can say that the ratio AE upon EC is equal to AF upon FC. Now if we add 1 to both the sides of this equation and take LCM, we get AE plus EC upon EC equals to AF plus FC upon FC. Now from diagram, if we see, AE plus EC is the line segment AC, and similarly AF plus FC is also the same line segment AC. So we can say that EC is equal to FC. Now this is possible on the same line only and only if E and F points coincide with each other, means they are the same point. So we can say DF and DE are same line, and as we have constructed DF as a parallel line to BC, we proved that DE is parallel to BC. So the converse of basic proportionality theorem, which says that if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle, is proved. And there is another method to prove this converse of basic proportionality theorem, and that is by using similarity of triangles. We can prove triangle ADE and triangle ABC similar by the given ratio and one common angle A, that is SAS similarity rule, and then we can say because of equal corresponding angles, DE is parallel to BC. Now let us see how can we apply the converse of basic proportionality theorem in various different questions. The first question says that in the given figure, DE is parallel to OQ and DF is parallel to OR. Then show that EF is parallel to QR. So we are given with two pairs of parallel line segments, DE parallel to OQ and DF parallel to OR, and we need to prove that EF is parallel to QR. Just look at this triangle PQO, in which we can use one of the given details, that is DE parallel to OQ. So using basic proportionality theorem, we can say PE upon EQ is equal to PD upon DO, and let's say this as result 1. Similarly, if we see the triangle PRO, then we have DF parallel to OR as the given condition. So again, using basic proportionality theorem, we can say PF upon FR is equal to PD upon DO, and give this as result 2. Now if we see both the results 1 and 2, the right hand side ratio is same, PD upon DO. So from 1 and 2 results we can say PE upon EQ is equal to PF upon FR. Now if we see the main triangle PQR and the result that we obtained from first and second results, we have two sides divided in equal ratios. So that is, in triangle PQR we obtained PE upon EQ is equal to PF upon FR. So here we use converse of basic proportionality theorem and we conclude that EF is parallel to QR, which is our required proof. Another question says that ABCD is a trapezium in which AB is parallel to CD and its diagonals intersect each other at point O. Then show that AO upon BO is equal to CO upon DO. So we are given with AB parallel to CD as the opposite sides of trapezium, and to prove AO upon BO is equal to CO upon DO, let us construct a line parallel to the given lines. So we construct EO parallel to AB. We have AB parallel to CD as given and we constructed EO parallel to AB. Therefore, we can say AB, EO and CD, all three line segments are parallel. Now see the triangle ADC in which EO is parallel to CD. So using basic proportionality theorem, we can say AE upon DE ratio is equal to AO upon CO ratio, and let's say this as result 1. Similarly, in triangle ABD, where EO is parallel to AB, we can use basic proportionality theorem again and say DE upon EA is equal to DO upon BO, or we can use the reciprocals of this proportion as AE upon DE equals to BO upon DO and give it the name result 2. On comparing result 1 and 2, the left hand side ratio is same in both the results. So we can write AO upon CO is equal to BO upon DO, or on cross multiplying BO and CO, we get AO upon BO is equal to CO upon DO. Hence, the required result is proved. Now this question can also be proved without any construction and without using basic proportionality theorem. This can be proved by using AA similarity in triangle AOB and triangle COD, so that if triangles are similar, then their corresponding sides are proportional. One more question based on this. It says in triangle ABC, D and E are 2 points on the side AB such that AD is equal to BE. If DP is parallel to BC and EQ is parallel to AC, then we need to prove that PQ is parallel to AB. So we are given with three conditions: AD equals to BE, DP parallel to BC, and EQ parallel to AC. And we need to prove PQ is parallel to AB. So let us say the proof. If we consider the first pair of parallel line segments given, DP parallel to BC in triangle ABC, we can write DP AD upon DB is equal to AP upon PC using basic proportionality theorem. Let's say it as equation 1. Now in the same triangle, if we consider EQ parallel to AC and use basic proportionality theorem, we can write BE upon EA is equal to BQ upon QC and name it as result 2. Now if again one more condition that is given in the question, AD equals to BE. Now if we add same number to both the sides of the equation, we get same results. Here we add ED line segment on both the sides. So we get AD plus ED, which is equal to EA from the diagram, and BE plus ED is equal to DB again in the same diagram. So if we see result 1, result 2 and these conditions where AD is equal to BE, we have AD and BE as the numerators in result 1 and 2 left hand side. And if we see EA is equals to DB, then we have EA and DB as denominators on left hand sides of results 1 and 2. So using results 1, 2 and this third result, we can say AP upon PC is equal to BQ upon QC. So using converse of basic proportionality theorem, we can conclude PQ is parallel to AB. Now let us revise what we have learned so far. So we have learned two theorems, basic proportionality theorem and converse of basic proportionality theorem. The first one, basic proportionality theorem, says that if in a given triangle, say for example triangle ABC, one of the side of this triangle is parallel to a given line or line segment. In this figure we can see DE is parallel to BC. Then under this condition, basic proportionality theorem says that the other two sides are divided in equal ratios. So we can conclude AD upon DB is equal to AE upon EC. Whereas the converse theorem says that if the two sides of a triangle are divided in equal proportion by a line segment, then under that given condition, that line segment DE is parallel to the third side of the triangle, that is BC. I hope you enjoyed this learning. Thank you for joining this session.